I press record.
Okay. So hey everyone, thanks for joining. My name is Karine Wallig. I'm helping with a lot of the community development stuff with the Apache Pinot folks. Thanks Naveen for helping put this together. So Naveen was a big integrative part of helping us organize this, and also shout out to Galvanize for Kelly. I don't think she's here right now, but big shout out to Galvanize. They also helped put this together. And we do have some folks here from the Pinot team. I mean, Pinot, it's Apache Pinot, so it's like an open source project. Neha Pawar, she is one of the, well, she is a PMC and Apache Pinot committer. So she's here today too. So if you guys have just general chat, I guess you could just put it in the regular chat to the panelists, and we can chat with you back if we have the ability to respond to it, if something. If you do have a question specifically for Ting, the presenter, please put it in the Q&A. That way people can vote it up or down. And at the end, during the Q&A, Ting can go through the questions. Ting loves good questions, and we're leaving a lot of good time for it. So feel free to ask if you have any kind of questions, and we can get to them at the end. I also put in a bunch of links for Pinot related resources, like the website, docs, Slack, blah, 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 blah. Please join our Slack channel if you guys have questions and you find this interesting. I'm also going to add in here, we have an intro to Pinot meetup kind of webinar coming up soon. And if you're interested in learning more beyond what you see today, kind of like a very deep dive into Pinot and a very intro level deep dive, please feel free to join. And that is the URL for that. And then I will also introduce our speaker today, if we're ready to get started. And then I guess Ting can tell you about what he's speaking about, since that's the entire topic. Okay, so Ting Chen is a software engineer at Uber's data team. He is a tech lead on the Stream Analytics team, whose mission it is to provide fast and reliable real-time insights to Uber's products and customers. And he is an Apache Pinot contributor. So please welcome Ting.
Thank you. Thank you, Karine. Can I share my screen now?
Naveen, he's the one in charge of this.
Okay.
Yes, you can share it. I believe panelists are allowed to share the screen. If not,
Who's stable? I got a message to say I was disabled.
okay.
Bob.
No,
All
you are.
permissions taken away.
Oh, okay. It's fine now. Yeah. Let me present. Send to presentation mode. Okay, where is the presentation mode? Okay, presents. Okay, everything's in order. Maybe I can get started. Hello there. So I want to say probably, yeah, this is very likely a global audience. Yeah, I see people from different time zones. I'm Ting Chen. So I'm an engineer at Uber's data team. And today I'm going to share our experiences on how to operate Apache Pinot at Uber and for our product. So actually, Uber has been a long time probably user of Pinot, as we have been using it for about maybe anywhere between 4 to 5 years. So we are really honored to come here to share our experience with you guys. So a little bit more introduction about myself. Yeah, yes, as Karine introduced, I'm an engineer, software tech lead at real-time data analytics team at Uber. So in my past life or career, I've also worked at the data infrastructure project at LinkedIn and Google. So basically, that's my a little bit about myself. So I think I earlier spoke with Karine. So this talk will basically be about half about basics about Pinot or I think about internal of Pinot itself as an open source software, and half of it about the use cases that we have here in Uber, and some like advanced feature. But I also would say it's about some unique feature we added to the Apache Pinot ecosystem, right? So this is going to be about a 40 minutes talk. So let me get started by setting a stage about what we do here as a data team at Uber. So I basically take this picture, actually pick this diagram from a recent published paper by a bunch of researchers and engineers at Databricks, Berkeley, and Stanford. And I like it because it basically gives you a very high level view of many tech companies, data teams, operations, and their scope of work. And in a high level, basically, it abstracts away a lot of complexities, but it shows a lot of essence of this kind of what we are doing. We are a team with about more than 100 engineers and a dozen services, right? And then the core asset we maintain for our business is the data, right? So the business data of Uber. So in that aspect, so the production engineers, operational guys, they funnel all kinds of data into this central data lake, right? Look at this picture. I think the most important abstraction they want to push out is the idea of data lake. So, and then in this data lake, the data will be stored there. And then now our data team comes in. We build all kinds of product to curate this data, transform this data, put them into good shape. Because our front end engineer and product really need this data to build all sorts of monitoring tools, intelligence tools to utilize the data. So this picture actually lists some interesting applications. It can be business intelligence, it can be reporting purpose, and also data scientists or machine learning engineers. So in this picture, I believe the author tried to put it, actually we also agree here. There are two kinds of main access paths to this data lake. One is like SQL based, right? So basically use very flexible declarative SQL language. Another way to use them is using more lower level programmatic APIs, right? But of course, things actually be more interesting in the real industrial companies, because I don't probably agree there's a simple binary division of machine engineer or data scientist. They only use programmatic API, for example. Actually, they also use SQL, right? Because SQL is so powerful, easy to use, and productive. So these talks actually focus on the left-hand side of this access pattern about the SQL access API and about how Apache Pinot is used in our data ecosystem to power this SQL API access, right? So this is the main stage. So with this reference data structure in mind, right? So actually this picture shows the actual implementation here in Uber we chose to do our data lake, right? So you can recognize this picture if you turn your head around 90 degrees, clockwise. So actually this, when you look at it, it's exactly like one implementation of what the previous diagram shows, right? So we have applications, right? Uber apps, internal monitoring tools. They come every second, constantly feed data into a transactional store. And then this transactional store will then propagate data into our data lake. And then in our data lake, actually, we have various kind of tools, open source tool like Apache Kafka and or Hive, this kind of Apache Hive systems. They become our data lake storage. And the nice things of Pinot is Pinot is able to digest data, ingest data from both kind of a variety of data sources. They be string-based Kafka or a traditional batch file-based Hive systems. Okay? We use Apache Pinot to store and transform the data. And from here, now the SQL API comes in, and for Apache Pinot, it supports both Pinot direct version of SQL and also the Presto SQL. So we have a lot of users, they rely on this SQL interface to build a product. Okay, next, let me talk a little bit more about the detailed, actually the needs, data needs from our Uber, I would say, communities, right? So for some background, right, Uber is a company with about 20,000 engineers and operations and basically business guys, right? So one unique feature, aspect of Uber is we have a lot of business operation personnel around the world, and basically they operate on our cities, right, to ride sharing and Uber Eats and so on. So for example, many of our business operation, they really want to derive insight. Like for example, for Uber Eats, they want to know what are the Uber Eats items abundant in their Uber Eats app cards in the past 10 minutes, right? So if they have this, they can like ping these users so that we can increase our sale. And also we have a lot of data scientists leverage our data lake so that they can capture metrics about the marketplace supply and demand information, like be ride sharing or be the Uber Eats delivery. And also like third group is like Uber actually production engineers. They also want to build various features like Uber pool hotspots identification for customers. So actually, when we look at all these demand, right? So one common thing is that somehow they can all be written in the form of SQL statements. And then that's why from here, they can start to use like Apache Pinot, right? And actually the next screen shows the actual product that we build out of the earlier like their demands, right? This picture shows one use cases for Uber Eats. So for Uber Eats, right? So basically our product allow every participating restaurant manager to see the sales information, for example, in their stores, right? So when you look at this dashboard, it shows, for example, the revenue. They saw the sales count in the past week, right? So, and then also they can see in the top selling items. So all these are data analytics product if you open the hood, right? So I think today, if like I really like to this joke, like if you really open order a peanut through a Uber Eats app, actually in the backend you will go through an Apache Pinot processing, right? So this is like the status how we use it today. And similar example, go to like our other application like Uber Freight. So in this app, again, users can build a dashboard. So to monitor the freight marketplace, and how many demand, how many supplies, and then for the demands, what's the pickup rate and their on-time discovery ratio, and so on and so forth. So all these are basically about insights from data analytics. Right? So I've shown you a few use cases, right? So this is like a very high level snapshot of the scale of like Apache Pinot operations here at Uber today. We have about 200 tables with many dozen terabytes of data in production. So, and I want to emphasize, right, each of these table, a lot of times for us is actually power entire end-to-end product at Uber. For example, Uber Eats a dashboard or freight dashboard. So any second we get about more than 1,000 queries, and we keep the query latency really low with the data flashed. So that this P99 freshness under 5 minutes means that as soon as user put data 5 minutes ago, we are guaranteed to surface them for queries. Okay, so this is like the scale of our service. So and let's summarize our user needs, right? So yes, we see a lot of user demand. User here means like Uber internal engineers, like they want to operate on these data lakes and using us for data analytics and insights. But we can roughly categorize their needs into like these 3 big circles. I'm here like, because a lot of users come to us, right? They first sentence they want to open the conversation is, hey, a real-time analytics team, we want a low latency big data query engine for our product. So actually what I mean by low latency, that when we, after a few years of operation, we really think what I meant is like, they want like a low injection latency, meaning that they want the data to be fresh. So they don't want like a data delay to be more than a few hours, for example. And at the same time, they also want like a low query latency, obviously, because they do not want to wait a few minutes for the query get returned back. And finally, they also want a good process latency, meaning that in a big company, right, you have a many like hundreds of engineers, dozens of teams. They really don't want like, they want to spend a whole week, for example, to set up a Pinot table, right? They want self-service. So with these, I think that's why we feel that Pinot can meet all the three demands like I mentioned earlier. So in the next few slides, I'm going to transition to introduce a little bit more about the internal of Pinot to let you understand why Pinot is in a good place to serve our user need. Right. So a little bit history about Pinot. Pinot actually was invented at LinkedIn. By the way, I did not participate in the project when I was an engineer there. But in Pinot, in LinkedIn, Pinot actually serve a lot of customer-facing product, like their member profiles, and there are also internal tools. So, and today, actually, there are a growing number of companies in the industry using Apache Pinot today. LinkedIn, obviously, and Microsoft, of course, modular LinkedIn. And we also have a growing company of like Uber, in China, Weibo use Pinot, and other startups. I feel this list is still growing. I think this company, right? So when they make the decision to choose Pinot, I believe one of the, of course, their reason is basically the unique feature of unique design feature of this system. Basically, it's a distributed real-time online analytical processing engine. So basically, I will start to introduce more about this concept in the following slides, right? So this slide shows a very high-level view of Pinot. So as I said, right, Pinot is a very good fit for today's data lake system. So this basically picture shows various components about Pinot. Let me like start from the data injection part. So Pinot today is actually able to inject data from various sources. They be stream source like Kafka, or Azure Event Hub, or other like cloud vendors like Google Upsert and so on. And it also is able to ingest data from like traditional, more batch-oriented file system like Hive files and so on, right? The real-time stream data combined with this batch data basically is the unique, I believe, indicator of the so-called Lambda architecture. Essentially, it serves the need of customer about their data requirement from a few seconds old to as old as like a years earlier, or maybe 1 or 2 years earlier. So by doing like these powerful data injection, then Pinot can host a long retention of data. So after data is ingested, Pinot have this like control plane, which basically utilize Apache Zookeeper, basically, and Apache Helix. Basically, Apache Helix is a library which manages Zookeeper data. Basically, all the cluster state, hundreds of machines are stored in Zookeeper through Helix. And also about like these terabytes of data, they are secondary information. So this control plane is really a solid one. Finally, Pinot as a query engine, it has a unique feature. Unlike other systems, it basically coupled its storage with compute. Basically, in this real-time server, it has both the data ingested through strings, and also the compute power and the CPU power to like basically do the query processing. So basically, this is the data plane. So you can roughly see, right? So these are the three main components: the data plane, control, and for example, and finally the data injection modules of Pinot. Right? So as a distributed system, like we really, as operator here at Uber, right, we find that a nice feature of Pinot is really horizontally scalable. So meaning that you can actually throw machine to solve the problem in emergency or in a case you want to scale up, right? So basically, this is a really make our life easier. So today we have like probably about anywhere between 500 machines per cluster, and to meet our customer demand. And another feature of linking about Pinot is really useful is that it provides performance isolation through this concept called tenants, right? So each Pinot cluster, meaning that the installation of Pinot, is divided into several tenants. Each tenant is basically itself is, you can think about it's a working unit. Different tenants don't share resources except the control node. So that means that when a query comes in, right? So any problem with tenant A because of any costly query will not affect tenant B. So this is a really nice setup or feature, I would say, for production systems. Because here in Uber, right, we operate on probably anywhere between 10 to 20 tenants. Some of them is like a very high tier. We want to guarantee the SLA, but others may be lower tier. So, but we make sure that different tenants will not interfere each other. So after understanding of this distributed system setup, let's look a little bit how one query is run on Pinot, right? So in Pinot, when a query comes in, so basically you will first hit the broker, and the broker may get basically the state of the cluster from this node called Helix, and then basically you will do a scatter and gather basically to send the query to all those hosts, right? So that it can, each of the data servers will answer the query. And then the broker finally do the merge and return to the client. So another important feature I want to show on this slide is that Pinot is actually a replicated data store, as you can see this picture, right? Each actually of the box of the same color actually are the replica of the same piece of logical data. So as you can see this picture, right? The data S1 go replicate twice, and so on for S2 and S3. What this means is that whenever one single node is down for a two replica system, the system can still function and like normal, right? This is actually a good news for us, because when you replicate more, then basically you allow a few more nodes down, and your engineer do not need to like wake up in the middle of the night just because a single node is down, right? So this is how this is the main way Pinot provide data availability and robustness. Right. So after seeing the whole distributed system, let's zoom down to one single Pinot node. So as many of you probably have known, right? So this idea of using columnar storage to data compression is a well-tested idea. So Pinot also used this idea of doing columnar storage. By columnar storage, it means that unlike traditional database systems, Pinot does not store data row by row. You need to flip ahead, Pinot store data column by column, right? Let's take this example, right? So in like a Pinot terminology, the most basic unit of storage is called a Pinot segment. A segment is basically, you can think about, is a partition of Pinot data. So most of the time we use like time-based partitions, right? As you can see, there's a time column here. We partition the table by time. So, and then Pinot then will, for each segment or each partition, it will store the columns individually, right? So they take this page column, right? So this page column store the name of various scenarios, right? So in the original raw-based storage, you probably need to store the names, right, as basically raw strings. But Pinot can compress much better, because it first do a dictionary encoding, but turn this name of these or string names into like a dictionary IDs, right? Justin to become 0 and Kasha become 1, right? Now in the end, this column in the disk representation will be represented by a series of 0 and 1s, which is much more smaller than a series of strings, right? This is about storage of columns. And Pinot allow you actually also to do better data lookup by providing these index structures. For example, you can look up all the rows which has this Justin Bieber by using this so-called inverted index, basically mapped to a value from a value to all the rows contains the value. Pinot actually use this bmap to store the list of documents. Basically, in this bmap, right? So you have the bit turned on to be 1 for the position where the row actually contains the Justin Bieber column value. So, and then with all these, you can do further optimization tricks. For example, you can pack multiple bits together or use like runtime screens, like rolling map. So I believe you can go to look more detail on this aspect. But all in all, in our experience, right, in many of our use cases, we saw 10x plus data compression ratios versus raw store. This is great news for us, right? Imagine like you can like use only 10% of your machines compared with raw store to store the data. Right? So this is about columnar storage. And I think this is, let's go to another strength of Pinot, which is about Pinot indexing. So Pinot is actually a great tree which bear all kinds of indexes. This table basically lists a major type of index used by us to serve various kind of Pinot queries. So basically, this is even growing, ever growing around there. Now, I believe the major one here I have talked about is like inverted index. You can use to faster filter queries, right? So we also have index to serve aggregation queries, or like we have geospatial index recently added to serve Ubers, for example, geospatial queries to see where one planes are close to my map and so on, for example. And also JSON index, for example, to query JSON objects. So I will probably select one index type here, which is very interesting to talk a bit more about it, right? So this is about StarTree Index. So as I mentioned to you, a lot of our users are interested in doing data analytics queries, right? So this is like, what do I mean by that? This is one very contrived example, simple example of what a data analytics query to get the sum of impressions of all browser visits grouped by countries, right? So this is one simple analytics aggregation query. So if you like process this query on a normal table without any index, probably you have to scan all the entries on the table, right? And then do the sums. And it would take like minutes for big data, big table. So what Pinot help here is by he allow us to utilize its so-called StarTree Index. So on a very high level, StarTree Index idea is to do data pre-aggregation. So instead of doing the sum at the runtime, it pre-compute the impressions and group by countries and store them in the StarTree Index. So the idea is you try to trade off your space. The space here is used for index so that you can get better runtime query performance. So when you execute this query, now instead of doing like a scan, now you can do table lookup, which is much faster. So you can actually see more details about how a StarTree Index is built. And at Uber, actually, you found a StarTree Index can speed up our query like by more than 100 times. Right? This is pretty impressive. And basic idea about StarTree Index about it allow you to basically select from this whole spectrum of space and latency trade-off. You can have like more like data to be aggregated before the table is loaded, so that you can get latency. But also you can also like trade off a little bit space. You have a smaller index, but of course you pay a little bit more about your query latency time. So this StarTree Index is really useful because in our experience, we find a lot of our use case have their query pattern predetermined. So we know the customer queries beforehand. So in this scenario, it's really easy for us to plug in the associated StarTree Index by grouping according to the query. And this will benefit like thousands of queries following, right? So because for each of them now, we have the index available to serve them. So this is one of the interesting index we utilize. And there are many types of them, as I can list it in earlier table. So overall, I think the Apache Pinot is a very impressive product because it combines a very stable distributed system with many good like these data structures about index together. And then this form a very powerful 1-2 punch for us to solve our data and analytics need. So far, I think I have seen a lot of good things about Pinot. But to make it work in our company, right, to work in our data lake ecosystem, so we have to say that we have to sometimes throw in our own formulas, right? One example here is that if I didn't tell you earlier, Pinot's SQL today does not support general join. You cannot join 2 tables together. Right. So, and then of course, from time to time, our customer will say, hey, we want to like join 2 table resource together and let Pinot to query it. Then how can we do it? Right. To do that, at Uber, what we do is basically we try to leverage on Apache Flink. Basically, Flink is a string processing library. It allows you to join various sources together. Now you can do injection time join of different table strings and to form a single string. And then Pinot can consume it from this single string. So to many people have some background here, right? So this is almost like a database denormalization. You basically denormalize into one single table and serve it. And Flink also serve our needs by a lot of complex operations, because a lot of time user want to do complex transformation of columns on the source data, but Pinot does not support currently. So in those cases, we also rely on Flink to do the data pre-processing. All right. So this is about how you do using Flink. The next question we also face is that although Pinot SQL is very powerful, it covers a lot of patterns, but it's still no full Pinot or not full ANSI SQL compatible. It has only limited support for UDF. So one example is, for example, a lot of our customers, right, are very complex time functions, right? So usually today Pinot support is still limited. So to solve this need, right? So what we have to do is we have to combine Pinot with a more comprehensive SQL query processing engine like Presto. So Presto is a distributed SQL query engine for big data. So as I list in this table, right? So today Presto is SQL fully ANSI SQL compatible, right? So but Presto do have a problem. Basically, it relies on its underlying storage system to provide those query latency gains and data freshness. So what we do is we try to like combine the goodness of 2 like open source systems, Presto and Pinot, so that we can achieve like the best of the 2 worlds, right? And well, things seem to look so easy, but actually we spent quite some time iterating through this combination of Presto over Pinot. Because in our first iteration, for example, our idea is we just try to let Presto to fetch data from Pinot without any processing and use Presto's processing power in its Presto node to do the aggregation and so on. It turned out to be very, very slow. And it also caused a lot of scans in Pinot, and our data cluster performance suffered a lot. So in our second iteration, what we did is like we do a much better or intelligent data rewrite. So that when a Presto query comes in, for example, this is an aggregation query, we actually do a much better translation, so that we send entire like aggregation query to Pinot to leverage Pinot's own aggregation power. So in the end, Pinot can like return very small data back to Presto, so that Presto spend much less time on its combination or merging, right? So this is idea is called aggregation push down, meaning that we push down its aggregation to Pinot, right? So it turned out that by this, we'll actually leverage the best of the 2 systems, right? Pinot now is able to utilize its index, its own query execution. And then Presto now is able to do very minimum processing, and then return back to user while satisfy user for their diversified need for SQL syntax. Right, so this is about Presto over Pinot. And we do have occasionally have other demands from IP features not found earlier in Pinot. So one secret I also want to share with you is that in earlier, most of the data in Pinot is append only, meaning until the data is got deleted, you cannot like modify the data content. Right, so this has actually become a problem for us because in many of our applications like Uber Eats, we do require some modification of data state. So to do that, we introduce some like idea about so-called Pinot Upsert or update and insert, so that we can change the previous data ingested into Pinot, and at the same time we get low latency of update. So this is a recent contribution. It's available after Pinot 0.6. So I think if you check out, there's a detailed talk earlier this month about how it was implemented by one of our lead engineer, Yupan. Right? So this is another feature I want to like mention about join. I remember I told you Pinot today don't support full general joins of full tables. So, but from time to time, our user to come back to us to do join. And we actually find out many of these joins is actually so-called result declaration. So what they want to do is basically, for example, they get a row of data, but they want to get city name to a row so that the city name can be associated with a city ID. Right, so this is so-called result declaration by basing add some like features or attributes to a row. So this can be actually be modeled as a join of a so-called fact table, meaning a big table with a dimensional table, which is small, static about attribute of an entity. So today, actually, Pinot is able to do like a join of a big table, a fact table with a dimensional table. So the trick here we do is basically we introduce a new UDF called lookup UDF. Now you can look up from this dimensional table by a certain lookup key for a certain field in a dimensional table. So now you can basically use this lookup UDF to simulate the join behavior. So basically today, actually you can do like this declaration join. And then under the hood, right, what we did is basically we do a broadcast join by push this dimensional table to all the servers hosting the Pinot data, and then let the broadcast join to happen on the Pinot servers themselves. Right, this feature is also available recently. All right, so I think these are the two features that I mentioned earlier. There are many, a lot of goodness about Pinot, but I encourage you to check out on the basically the blog and basically a documentation on Pinot. And actually, this is probably the end of my technical talk today. But I want to like come back to my opening picture, right? To let us to have one more view of this data lake ecosystem, which in my opinion is probably the defining systems of today's data engineers, right? So as you can see, right, Pinot actually play a very unique role in this ecosystem. It provides very good indexing. It's a very robust storage engine, and it's distributed. So it's like it's very easy to work with other like SQL related product like Presto. And today for us, it provides our needs for business intelligence and the monitoring and so on. And actually, I think, as I said earlier, why I disagree with this picture is that finally, actually a lot of our data science engineers and machine learning engineers, they can also leverage this combination of Pinot plus SQL API to basically build their products, right? So I'd like to end it here. Finally, I also want to thank you the entire Uber team, real-time data analytics team for their contribution along years to build this whole ecosystem around Pinot. All right. So I think Karim already saw, but this is all the channels that you can reach out to get support from Apache Pinot. And from our experience, that we also want to thank for the community, because we can get very timely feedback and also help from the community. So this is actually help us to build our product here at Uber. And I would like to thank you here from Uber. And that's my end of my talk. Thanks.
I think that's amazing.
All right. So do you have any question? I believe probably we can enter the question.
Yeah, let me see if Naveen, are you here?
Yes, we are here. Means we have question answers which came through the users, and they have been posted as a chat, but I'm not sure like if all the users got the opportunity to see those answers.
All the questions that were posted in the Q&A have been answered by panelists. And there's some that are still answering. But if you want, we can either ask people to post questions now that we can direct directly to Ting, or we can ask people to turn on their microphones if they want to ask verbally a question. They can raise their hand. We have the raise hand thing. I think that might be an
Yes,
option too.
So whatever way we are open to all. If you want to talk, just raise hand. So we will allow you to talk. And if you want, in addition to the questions that has been asked through the question answers window, they can definitely go through and ask the new questions. And again, for Ting, I want, if you wanted to take any questions which you want to elaborate, which has already been asked, definitely that will also help some of the.
Sure. Yeah, maybe we can answer the live question first, and then after that, if we still have time, we can cover the question that already got asked.
That's a really good point, Naveen. So if anybody has any questions, you can either post them in the Q&A now, and we'll ask Ting directly, or you can raise your hand, and then and then you can actually ask verbally. You can turn your mic on and ask verbally. That works, right? We can give people, okay, there's already a question coming in. Ting, do you need us to read it, or do you want to?
Would you mind to read for everybody? So yeah.
Oh, we already have panelists that are on it. They're just like responding.
Yes.
Already. Mayank's been responding to a bunch. Neha, Jackie, there's a bunch of people.
So let me read the question for him. So there's an anonymous attendee is asked, what's the normal data latency for real-time segment?
I believe our SOA is about 5 minutes, but in our SOA meaning our guarantee to our user is around 5 minutes. But in our experience, we can achieve probably around tens of seconds. When data appear in strings, then we can ingest it and serve it. So yeah, that's our like operational experience.
If anyone has questions, you can post now in Q&A or raise your hand. The raise hand thing looks like a high five. Looks like there is somebody with a raised hand, Naveen.
Okay, let me.
Shri Chari.
Hey there, can you hear me?
Yes, we can hear you.
Okay, quick question. So, I mean, clearly there's a lot of streaming data along with OLTP data. What are you doing for exception handling, or if there are timeouts through one of those sources? Can you talk about how you handle either loss of network or any of these unforeseen situations?
Okay, yes, sure. Yes, definitely. This is a very good question. Now, there are various different kinds of failures, right? So, of course, we are a operational company. Make sure that we need to very reliable ride sharing. So we have several levels of defense. So one is like in our company at Uber, we actually have multiple regions. We do so-called active region deployment of Pinot. So what we have is basically 2 identical copy of the data of Pinot anytime. So for example, if let's say East Coast of US is down, we have West Coast data center left, right? So this is actually the outermost layer of defense. Now, Pinot actually itself actually provides some like data redundancy, right? As I said, right? So for each copy of data, we replicate it 3 times. So that's why most of our failure is like a single node, for example, down. Actually, this become non-issue for us because we have other replicas ready to serve, right? So basically, this is the inbuilt feature by Pinot to use data replication to solve the problem. So I believe finally I want to go back to the tenant idea, right? So yes, you are right, because our cluster basically serve any customers. Like from time to time, some user will throw us a very expensive query. Will knock down one of our like set of machines. Here the tenant comes in because where we have isolation, that means that even one expensive query knock down one tenant, other machine in other like tenant can still serve other customer need, right? Does that answer your question?
Yeah, no, it does. It explains it from an infrastructure perspective, but what happens when you sort of have loss of connectivity for the applicant themselves? Let's say I'm ordering an Uber, I have lost network. How do you sort of solve for the latency lag in terms of data?
Yes, some of these questions probably is beyond Pinot's control. For example, you talk about data center. Yeah, we do have these cases, right? We have data center loss. Probably that would be more like a Uber infrastructure as a whole, right? So basically, again, I believe I will go back to the multiple region setup. That's I would say that's probably not the domain of Pinot application, but more like in general, a company's IT or basic service infrastructure setup.
Got it. Thank you.
So here, another question from an attendee, which is wanted to understand like features, like a comparison, comparison with the other streaming tools like Flink or anything that you can compare. With.
Sure. I don't know other two because I think from the diagram I show, right, this is the evolving landscape of like a data ecosystem, right? So if you want to like specifically compare with Flink, like we operate on Flink. So our experience, like Flink is really good for short-term data processing, right? If you look back maybe an hour or maybe let's say at the most probably a few hours, then Flink maybe can do the in-memory processing. But anytime beyond that, you do like a multi days lookup, look back, and aggregation. The Flink has issue in its like memory memory usage and so on and so forth. So in our like experience, it looks like Flink is good for stream processing, right? But if you talk about like long-term data analytics, Pinot is a better choice. So does that sound good? Or you want to compare other systems? But in general, I will again, so this is like an open field for a lot of systems to co-evolve today. Yeah.
That sounds good. Now the Kant has asked on the chat window, I'm not sure he has transferred to the Q&A, any recommendations on the size of a lookup table that is broadcasted to every node?
Oh, that's a great question. I don't know if my fellow engineer who implement these features here, but yeah, I think I knew a little bit. But in general, like several constraints here, right? So Pinot is an in-memory store. Obviously, the lookup table should not be bigger than a physical machine's memory, right? So that's why we emphasize, right? This feature is mostly useful for dimensional like tables. Think about CT to ID to CT name mappings, right? You can have like maybe at least a few thousand tables. But beyond that, I think a few gig should be really fine. Yeah. So, but if you go beyond, like you want to have a more bigger than memory size of dimensional table, that won't work. Yeah, well.
Okay, so on the Q&A, we It is more related to the framework. I'm not sure if you wanted to take that. So it is about your architectures, your data lake architecture, which you have shown on your presentation. And there is interesting questions they wanted to understand if there is Apache Pinot Uber from other framework which try to do the same thing similar to data lake. I think that can be answered offline.
Yeah, I think yes, I agree. So because this data lake just give you a high level idea. I mean, it's not like concrete implementation. Yeah.
Yeah, that's a very interesting question. And I personally also wanted to know this answer. Thus, what is the performance impact when working with Upserts?
So far, I probably will refer you back to the meetup for Upsert for details. But I
can
think,
add that. I can add that link.
yeah, exactly. Thank you. But in general, I think the latency is still like within seconds. Yeah. So I remember, probably I want to understand this question. Are you talking about query latency or injection latency? So injection latency means when do you want to see the data to be refreshed and be, for example, updated? So on that, I think probably Yupeng from our team will be in the best position to answer our question. So please refer to his meetup. But I think from my understanding, the injection latency lag is also really like within minutes range, right? So yeah, so that's the high level I believe idea we have already measured. So
yeah, I think both the ingestion latency and I would say overhead of ingestion and query execution is very low. I don't think you can actually notice that.
yeah.
Okay, so we are still waiting for a few more questions. Definitely their panelist has been answering on the Q&A directly.
Yeah, thank you panelists for being so relentlessly. Look at that. All the questions have been answered before they were even asked.
These are becoming like a booklet. You can just go through answer of all your questions. They are really wonderful questions asked by our attendees.
Yeah.
Really want to thank them and encourage them while that our panelist and technical team is here. You are encouraged to ask as many questions as you want so that you can understand the exact understanding of how the working of Pinot and the architecture which is used by Uber. So I don't see now the inflow of the questions after the last one.
Yeah, and if anyone has any other questions like after this, feel free to join the Pinot Slack. You can always ask there. A lot of the folks that we're answering here are community contributors in the Pinot Slack too. So, it's always an option if you would like to. I'll repost it in there just to make sure that people have it. I think I already posted it like 6 times, but what's one more?
Yep.
And also the Intro to Pinot meetup that's happening next week. I'm also going to post in the chat.
Yeah, definitely. That will be great. And I'm also going to post these links on the meetup. So in the chatting options, so you can refer it back in case you lose when we close this session. Or there is an option in the chat. If you know that there is a save chat option, you use that. That way you are able to save all the chat which has been created so far.
Cool. I also actually copied a lot. I copied a lot of it and I took notes.
Right. So in case like every attendee can create a save chat, this is 3 in the right-hand corner. You just press save chat and all the chat and links you can save it for reference in future. Now, as we do not have any further questions from our attendees, so now if like Etienne want to have some closing thought and then Karim can take over to give, as he already have time to time telling about the formally announce the upcoming meetups.
Yeah. Thank you, Naveen, for helping put this together. This is awesome. I actually really like this format with like the chats and everything. Leon commented that there is no option for save chat available. If you have further questions that haven't been answered, just join the Slack. There are amazing people there that are super, actually, a lot of the people that were answering questions today are, and also Ting is there. So if you have more questions for Ting, you can ping Ting. Sorry, I had to make a pun. Yeah, that was a really good presentation, Ting. Thank you so much. That was really, really good. Very insightful and very condensed with a lot of information, which is cool. And Naveen, thank you so much for putting this together.
Yep, definitely. Like I will also do the same. It was such a wonderful presentation, like within 30 minutes or 40 minutes, like it's a abundance of information. You explained like multiple architectures, multiple tools in a very simple, even then went into the query level details. So very simplistic way. It's a very, very, I think, say nicely crafted presentation.
Thanks for making it happen, Naveen.
Thank you.
And Ting.
Yeah.
And everybody who answered all the questions.
Yes, thank you for the panelists. Actually, they share a lot of, actually, their answer amazing. Yeah. So I learned
They were so solid. I was really impressed. It's like you have a whole entourage with you, Ting, and people are asking questions, but they're already answered.
Yeah, right. And like you are going to post your next. So now one of the thing is like will definitely not only like this technology, because the meetup that we are performing, definitely we are going either big data or analytics or any technology related to the artificial intelligence, deep learning or machine learning, that we have been talking and getting speakers time to time. So if Uber team has any other area where they wanted to share their contribution or they wanted to bring something, I know they are primarily focused on this tool and architecture, but like they are happy to welcome, and we are running our meetups in multiple time zone, DC and San Francisco, and different European countries. So if they wanted to just come up, you can either share things with Karine, and I think I feel now pretty much good understanding with like a repo with Karine. So I can contact her, or they can reach out to me directly.
Yeah. And we could also work on putting something together a little bit earlier in the day too for.
Right. So with this, like from my side, I want to thank everyone, and now say finally, Karine, to good night to everyone. That's it's a wonderful presentation. I personally loved it, and hopefully I will join furthermore to get more insight on a specific topics. But yeah, this was a pretty good insight in having the architecture, and hopefully I will work on in future upcoming months on this architecture to provide a real-time analytics on some of the applications I'm working on.
Exciting stuff. Naveen sold.
Yeah, I was sold. I love technology.
I mean, it's really cool. It is definitely really cool. And Ting did a great job presenting it. So
with thank you. Have a wonderful evening and wonderful night. And we will definitely see you soon in upcoming presentations.
okay. Bye, y'all.